Alright, 7.1. Apply the Pythagorean theorem. A Pythagorean triple. A Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy the equation c squared equals a squared plus b squared. Or you guys have probably heard it, a squared plus b squared equals c squared. This is a Pythagorean theorem. Hopefully you guys have this memorized. If not, memorize it. Okay? I'll do a quick example. Find the length of the hypotenuse of the right triangle. So we're going to use c squared equals a squared plus b squared. C is always the hypotenuse. The hypotenuse, if you guys remember, is the longest side of the right triangle. So in this case, it's x. So this is x squared. A and b, it doesn't matter which one you put as a, which one you put as b, as long as a and b are the legs. So I'm going to put 7 for the first one and 24 for the second one. 7 squared is 49. 24 squared. $576. Add those together. $625. Yep. Now, if you take the square root of this, the square root of 625 is 25. Because 7, 24, and 25 are all three positive whole numbers, this would be considered a Pythagorean triple. Okay? It is not necessary to memorize Pythagorean triples to solve these problems, but it does help. It works kind of as a shortcut. And as we do more problems, you'll see what I mean. Alright, I think you guys can do this one. Let's go on to page 2. Okay, a 6-foot board rests under a doorknob, and the base of the board is 5 feet away from the bottom of the door, as shown in the diagram. Approximately how high above the ground is the doorknob? So, this is what we're looking at. We have c squared equals a squared plus b squared. As you can see, 6 is the hypotenuse. So that's what I'm going to plug in for c. The distance from the door, I'll make that a, is 5. And the height of the doorknob is what we're trying to find. So I plugged everything in. 6 squared is 36. 5 squared is 25. I'm going to subtract 25 from both sides, and I get 11. So the square root of 11 is what x is. So let's pull out the calculator. Square root of 11 is about 3.32. Or we'll just put 3.3. Okay. Alright, so the board is resting against the doorknob about 3.3 feet above the ground. Alright, I'll let you guys do this one. Let's go to page 3. Find the area of the isosceles triangle with side lengths 16 meters, 17 meters, and 17 meters. Okay, so they've drawn a sketch for us. By definition, the length of an altitude is the height of the triangle. In an isosceles triangle, the altitude to the base is also a perpendicular bisector. So the altitude divides the triangle into two right triangles with dimensions shown. Okay, so this is what we have. We have a side of 16, 17, and 17. This altitude divides this side into 8 and 8. Okay, because it's an isosceles triangle. So, I'm going to focus on just one of these right triangles and use the Pythagorean theorem to solve it. So if you look here, my hypotenuse is 17, and my legs are 8 and h. So let's plug that in. C squared equals a squared plus b squared. My c is 17. H is my b, so a is going to be 8. 17 squared, I believe it's 289. I'm right. Yay. 8 squared is 64. Let's subtract. 225. Alright. The square root of 225, I believe, is 15. Yep. Oh, and I forgot to write that we subtract 64 from both sides. There we go. So, this is the height. Now, the reason we're trying to find the height in the first place is because in order to find the area, hopefully you remember the area of a triangle is 1/2 base times height. We already have the base. The base is 16. And now we know that the height is 15. Okay? So, 16 times 15, I'm just going to use the calculator. $240 divided by 2, 120. I divided by 2 because I'm taking half of whatever this is. So, we've got 120 square meters. That's the area. Okay, these are Pythagorean triples. I highly recommend that you memorize these. Okay? If you memorize these 4 triples, it will make your life so much easier when you're dealing with the Pythagorean theorem, any type of right triangle. Okay? This is actually the one that we did in the example on page 1. I'll go back real quick. See? 7, 24, 25. Okay? This one in particular, 3, 4, 5, this is the most common one. And as hopefully you can tell, the column is just multiples of the one that's in bold. So 3, 4, 5, if you multiply all 3 of those by 2, you get 6, 8, 10, sorry. If you multiply by 3, you get 9, 12, 15. You multiply by 10, 30, 40, 50. You can multiply these by any number. Okay? And the same goes for the other triples. So if you memorize just these 4, you can figure out the rest of them just from these 4. Okay? Alright, let's go on to page 4. Alright. Find the length of the hypotenuse of the right triangle. Okay, we have 45, 24. Both of these numbers can divide by something. If I was to divide 24 by 3, I would get 8. 15 divided by 3, that gives me 15. Now, 8 and 15 are part of a common Pythagorean triple. If you look at this chart here, I have 8, 15, 17. Okay? So you know that the triple being used here is 8, 15, 17. Now you have to keep in mind that you divided by 3, so in order to get x, you have to multiply by 3. 17 divided by 3, let's see. 51. So x is 51. You can figure that out without ever using the Pythagorean theorem. It's a shortcut. Now, if you don't see that, then you could just go ahead and use the Pythagorean theorem. 45 and 24 are kind of big numbers to have to multiply, but that's another way you can do it. It just takes a little bit longer. Okay? A common Pythagorean triple, 8, 15, 17, we just figured that out. Notice that if you multiply the lengths of the legs by the Pythagorean theorem, or by 3, you get the lengths of the legs of the triangle. 8 times 3 is 24, 15 times 3 is 25, so the length of the hypotenuse is 17 times 3, which we already figured out is 51. Now this is the other way. 24 squared, I'll just tell you guys, is 556. 45 squared is 2025. You add them together, you get 2601. You take the square root, you get 51. This also gives you the answer. It's just longer and you have to deal with bigger numbers. Okay? Alright. I'll let you guys figure out the last 2, and that's all.